Hello and welcome to today's Telecoms.com Intelligence webinar. My name is Tim Skinner and I'm the Content Manager for Telecoms.com Intelligence. Today we're going to be talking about Wi-Fi calling and how operators can herald in a new era of voice and messaging services by maximizing the integration of emerging network technology. Next generation Wi-Fi calling allows mobile operators to provide voice and text messaging services through any Wi-Fi network, even when users are roaming abroad. We'll be covering how operators will be able to utilize the same IMS platform used for voice over LTE services, as well as the specific architectures involved with Wi-Fi calling and what the various benefits and considerations there are when deploying Wi-Fi calling. We'll then be looking at how Aptilo and Mavenir have addressed the challenges of real-world deployments with features that meet and exceed industry standards, before rounding off with some lessons learned from the world's first next-generation Wi-Fi calling deployments. Joining me today are two pros from the realm of Wi-Fi calling. Johan Terv is the VP of Marketing for Aptilo, a position he has held for the last 8 years. In his 25 plus years of experience, he's been heavily involved with the development of enterprise-grade VoIP solutions. Ram Nagarajan, meanwhile, is a Senior Manager of Product Strategy at Mavenir Systems, where he's responsible for core product management of next-generation IP-based 4G LTE networks. Ram has 15 years of experience in the telecoms industry, and prior to joining Mavenir, he was leading mobile core network planning and service optimization teams at Nokia Networks. With these two at the helm today, you're in great hands for what will be a fantastic presentation. At the end of the webinar, we'll have some time for Q&A with Johan and Ram. You can submit a question at any time during the presentation. Simply type your comment into the dialog box you can see on this page. Responses from either speaker will appear at the end of the presentation. So, Johan, it's over to you.
Thank you, Tim, for the kind introduction. My name is Johan Terve, and I am VP Marketing at Aptilo Networks. Ram from our partner Mavenir and I will try to give you a broad perspective on Wi-Fi calling, from what it is to how operators have deployed it. We are all very excited. Telecoms.com have informed me we are going for a record number of attendees for today's webinar. So let's start with what is next generation Wi-Fi calling. Many were impressed by T-Mobile's bold move in September 2014 when they began their Wi-Fi Unleashed campaign and introduced the next generation Wi-Fi calling with an IMS from Mavenir. At the same time, Apple released native support in Apple iPhone 6 for Wi-Fi calling. Recently, Samsung launched similar support in some Galaxy models. This is truly a game changer for mobile operators in that now they can use any Wi-Fi network to reach subscribers with voice and text SMS services. Voice over Wi-Fi has been around for many years, using a voice application that can be downloaded to the device. This is still a good starting point for many operators. Ram will talk more about the evolution of Wi-Fi calling later. However, next generation Wi-Fi calling has native support in the handsets and works as an add-on to the voice over LTE service. People use the same phone number and dialer that they are used with for a cellular call. First out with native support for Wi-Fi calling in the device was Apple with the iPhone 6. Some Samsung Galaxy models also have native support, but the majority of handsets are expected to follow within the next 6 months or so. Until then, it is possible to use Wi-Fi calling apps on devices that lack this support. Let's look at how Wi-Fi calling is working with iPhone 6. The operator needs to enable Wi-Fi calling and can provision settings over the air to the subscriber's iPhone 6. The user can then enable and disable Wi-Fi calling with a simple switch in the settings of the device. The only way a user will know that she is using Wi-Fi calling is when the operator icon on the device itself is followed by a Wi-Fi calling symbol. In T-Mobile's case, this is the word Wi-Fi, but we have also seen from some of our ongoing trials that the word Wi-Fi call, so this differs from operator to operator. And again, it is a seamless user experience using the built-in support with the same dialer and the same phone number used for cellular calls. Next generation Wi-Fi calling works as an add-on to the voice over LTE service and utilizes the same anchor point in the mobile core and the same IMS. This is why calls can be seamlessly transferred between LTE and Wi-Fi networks without any interruption. There is also native support in the device for voice over Wi-Fi and voice over LTE, and an automatic and seamless transfer between the two. Operators do not need to install and manage a single Wi-Fi access point. With next generation Wi-Fi calling, voice communication is secured through an IPsec tunnel that works transparently over any Wi-Fi connection. The operator needs to add a so-called EPDG gateway, which terminates the IPsec tunnel, and establish a connection with the packet core through a tunnel. Next generation Wi-Fi calling also requires an IMS system, which handles the voice, text, SMS, and video services and connects the call to the PSTN when required. The operator also needs to add a 3GPP AAA, which authenticates and authorizes the user for Wi-Fi calling services. More about this function later. We will now talk about some of the benefits of Wi-Fi calling, both from the user and the operator perspectives. Let's start with the end user. Wi-Fi calling provides several benefits to me as an end user. With Wi-Fi calling, the cellular voice text services will reach into my home through my very own Wi-Fi network. This means that I can cancel my landline and save money. Next generation Wi-Fi calling is seamlessly integrated into my smartphone, and the calls will just continue without any interruption when I switch between the LTE and Wi-Fi networks. If my operator applies the same business model as T-Mobile, then I can make calls abroad using local rates. This is of course a huge benefit for me as I travel a lot. When I have a good Wi-Fi connection, the voice experience will be even better than I am used to, as I am leveraging HD quality voice and have faster call setup. So let's talk about the benefits for the operator. The main reason for service providers to deploy Wi-Fi calling is to get enhanced indoor coverage and more satisfied customers. This is becoming extremely important as many subscribers from the younger generation are giving up their landlines. They look for a provider that can give the best coverage in their home. A Wi-Fi call should be charged at the same rate as a cellular call, and the trend is clear. More and more operators have switched to a flat fee voice plan. This has paved the way for Wi-Fi calling, as there are no longer any revenue to protect. The exception is, of course, for roaming users. Wi-Fi calling, the operator has no cost for roaming and may choose to charge users when they are abroad at the same rate as if they were at home. This can be a smart move. Users are generally using OTT applications such as Skype when they are traveling anyway. The revenue the operator will lose from incoming calls will most likely be recouped as they attract new subscribers. Operators that have planned to implement femtocells or distribute antenna systems to cover subscribers' homes can now make large savings in both CAPEX and OPEX by utilizing a network that is already there, the subscriber's own Wi-Fi network. Service providers can now concentrate on deploying small cells in dense areas such as stadiums and shopping malls. These venues may be more challenging in terms of Wi-Fi quality for voice than the home environments. The combination of flat fee voice and Wi-Fi calling puts service providers back in the driver's seat. It's really no reason for subscribers to use OTT applications like Skype for voice calls. Operators have been forced to accept the fact that OTT players utilize a network that they have made huge investments in. Now it's payback time. For the first time, operators can now utilize something that they have not invested in. Wi-Fi is everywhere, and service provider can use it for their voice services. It is a relative low barrier for an operator with IMS and VoLTE services to implement Wi-Fi calling. The only thing they have to add is one or several ePDG gateways and a 3GPP AAA. This is why I think that most operators with existing IMS will offer Wi-Fi calling within the next 24 months. And the first movers in any country will gain competitive advantages and attract new subscribers. The rest will need to follow. Note that Wi-Fi calling is not only for mobile operators. We see an increasing interest also from cable and fixed line operators. I will now turn the presentation over to Ram, who will talk about the evolution of Wi-Fi calling. Ram?
Thank you, Johan, for that nice introduction. Hi, everyone. My name is Ram Nagarajan, and I'm Senior Manager, Product Strategy at Mavenir Systems. Unlicensed mobile access, or UMA, is dead today, and one of the primary reasons for that was the limited device support that didn't allow it to penetrate mass market. First Gen solves a critical problem that is still relevant today, the problem of network congestion, especially indoors, directly links with customer satisfaction. Taking T-Mobile as a classic evolution example, they reap the power of having an all-IP IMS core, which is the basis of first-gen Wi-Fi calling. They launched the first-gen solution, which was functionally very effective. You could have an IMS client installed on your standard phone. So an open standards-based approach was really the key here. As first-gen was growing in popularity, they innovated and transitioned into next-gen by introducing A, Apple Wi-Fi calling device support, and B, mobility between Wi-Fi and LTE with the introduction of the ePDG and AAA. A peek into the future will introduce traffic steering capabilities where devices can make intelligent selections on the access network based on dynamic policies, adding the access network discovery and selection function. From a services standpoint, we are evolving from a pure text and voice to video to rich communication services, which allows you to do services around instant messaging, presence, and content share comparable to WhatsApp. Adding WebRTC, extending the service capabilities on standard browsers. So just to set the stage for the upcoming discussions, I start off with the reference 3GPP end-to-end architecture of Wi-Fi calling, and we will also see how that relates to the generations discussed. You have your Evolve Packet Core EPC domain, the IP Multimedia Subsystem IMS domain, and the Legacy Circuit Switched CS domain, all closely intertwined. Next Gen entails the integration of Wi-Fi access into the Evolve Packet Core with the introduction of the Evolve Packet Data Gateway, or ePDG. The ePDG connects towards the untrusted Wi-Fi network, like the one you have at home or in a public place like an airport, providing security with IPsec tunneling to the UE. The PDM gateway connects to the IMS domain, which hosts your session control and call routing functions. The AAA is used for the subscriber authentication using EAP procedures. In the IMS domain, you have your application servers, which lend the service intelligence. The telephony application server, or TAS, for voice and video, and the IPSN gateway for messaging. First generation advocates a direct access method without the involvement of EPC, where the client is directly talking to the IMS core over the internet. This then relies on security protocols at the IMS layer like TLS and SRTP. One may also notice that first gen has a logical evolution path towards next gen by the introduction of the packet core elements. There are a number of practical considerations for the deployment of Wi-Fi calling networks. How do the users have the exact same service experience around voice, text, that they're so used to in the 2G and 3G world? Service parity is key and table stakes for launching a successful Wi-Fi calling service. Then we ask the question, does one need mobility? Here we are referring to the ability to maintain your ongoing voice call as you move in and out of Wi-Fi coverage. It's not a must-have, but definitely a good-to-have. It's the next step of evolution, next-gen Wi-Fi calling, and is offered as an additional service now on the Apple iPhone 6 with seamless mobility between Voice over LTE and Wi-Fi calling. What about QoS? Wi-Fi doesn't offer the end-to-end QoS that we typically see in an LTE network. So is that going to be a gating factor? Well, maybe not. For years, people are making voice-over IP calls on over-the-top OTT apps like Skype and Viber without end-to-end QoS. And the fact of the matter is, consumers are relatively accepting of OTT voice quality over Wi-Fi. Johan will be sharing more insights on QoS later on. And then you have the regulatory considerations, such as emergency calling. Some operators have taken a simple yet practical approach where subscribers have to manually add an emergency address like their home address. We will also be seeing some location aspects around this topic. Now, hopefully, everyone knows a bit more about Wi-Fi calling. It's now high time for us to share some of our expertise from real-world deployments. Johan?
Thanks, Ram. Now let's take a look at some of the key challenges while deploying a Wi-Fi calling network and stitch together our experiences. I will start talking about the authentication and authorization of Wi-Fi calling service and the quality of service aspects of Wi-Fi. Then Ram will continue with how to get the actual Wi-Fi calling service to work. So let's talk about the 3GPP AAA function in a Wi-Fi calling scenario. It's important to understand that it's two separate processes in Wi-Fi calling. First, it starts with that the user connects to any Wi-Fi network. This can be outside the operator's control, for instance, in residential, office, and hotspot networks. When the client has IP connectivity, the 3GPP AAA authenticates and authorizes the user for Wi-Fi calling. It is important, again, to understand that these two authentication and authorization processes happen independently of each other. The 3GPP AAA plays a crucial role in the voice service setup. It provides interface and interaction with HSS for IPsec and GTP tunnel establishments. The later tunnel may also be based on PMIP. It authenticates a SIM-enabled device with a HSS using SIM authentication. It retrieves user profiles and mobility parameters from HSS to authorize the device to connect to the relevant packet gateway and IMS APN. We know from our 100+ carrier Wi-Fi deployments that you often need to be beyond the standards in real-world deployments. And we believe that Wi-Fi calling is no exception. The Aptilo SMP Wi-Fi calling solution provides optional smarts, such as policy lookups. In reality, policies many times reside on multiple places. The Aptilo SMP can look up policies from multiple sources, such as CRM systems and policy management systems, and then provide a policy decision for the Wi-Fi calling service. Aptilo SMP also provides methods for allowing non-SIM devices provisioned with a Wi-Fi calling app into the Wi-Fi calling service. And in addition to support for HSS, Aptilo SMP also performs authentication via HLR. And for operators that owns their own Wi-Fi footprint, Aptilo SMP can, in addition, take care of that first process I was talking about initially, the authentication and authorization of users and devices for accessing Internet over the Wi-Fi network. Quality of service. Is it an issue? Well, this is one of the most common questions we get from our service providers about quality of service. And you can always regard a glass as half full or half empty. It is true, Wi-Fi has limited end-to-end quality of service control capabilities if you compare to a cellular network. But it's also true that normally there is limited quality of service guarantee for indoors anyway for cellular, if they are served by macro base stations. In fact, modern buildings can reduce the signal by as much as 30 decibels. This means that if the power is 1 watt on the outside of the building, it will be 1 microwatt in the inside. For operators that run their own Wi-Fi network, there are some opportunities to control quality of service. Standards such as Wi-Fi multimedia, WMM, and the fact that they can send vendor-specific attributes to the equipment means that they can better control the quality of service. So how about capacity? Is it enough in the Wi-Fi network? Yes. There are many times excess capacity in the Wi-Fi networks. Let's take the home Wi-Fi network as an example with a broadband connection of, let's say, 10 megabit per second. This connection will fit 1,000 calls or over 300 HD calls. I think that service providers need to come to terms with the lack of quality of service control in Wi-Fi calling and instead set the right expectations with their customers. Wi-Fi calling provides mobile voice services wherever you are connected to Wi-Fi, but only to the capabilities of that Wi-Fi network. Ram will now talk about the other challenges and considerations for a well-working end-to-end Wi-Fi calling solution. Over to you, Ram.
Thanks, Johan. Now we come to service parity. Subscribers really expect the same service irrespective of the access type, whether it's 2G, 3G, LTE, or Wi-Fi. So in addition to your basic call and SMS, you have all your supplementary services, prepaid, ringback tones, and whatnot. Customers really expect all that to work seamlessly. Our Wi-Fi calling solution is designed to provide service to the mobile subscriber's existing phone numbers. When the subscriber's Wi-Fi calling client is IMS registered, calls will be handled by the IMS core network. When the subscriber is not registered in IMS, calls would be handled by the circuit switch network. So irrespective of domain, he or she should be reachable on the same number. Well, how does all this come together? We have experience in deploying a number of voice over Wi-Fi and voice over LTE networks. And one thing I can tell you off the blocks is that no two networks are really the same. But the bottom line is this: you need to connect the IMS and the CS worlds together. It is here that the Mavenir's application servers play an important role by having the hooks into the legacy world, legacy network interworking. So how is that? The Mavenir TAS introduces an MSC-like avatar with the basic call state machine for call handling and screening. Support for supplementary services like call forwarding and call waiting. Camel interfaces for prepaid. The same logic extends to the IPSN gateway, as it has legacy map interfaces that connects to the legacy SNSE for delivery of messages to CS. So really, it's the flexibility to move in and out of the domains. IMS discovery and location. You can't take an off-the-shelf EPDG and EPC core and declare it ready for Wi-Fi calling. You need to establish a connect between the EPC and IMS worlds. The proxy call session control function, or PCSCS, which is your entry node into the IMS domain, is that connect. Leveraging our strong IMS background, we have incorporated key extensions to enable the PCSCS address to be sent to the UE, a procedure called PCSCS discovery. How do you handle location in Wi-Fi where you don't get the cell ID information? Yet another feature is to capture and preserve the UE public Wi-Fi IP address and send that towards the IMS core. The IMS core can then in turn use that public IP address for location mapping. This will determine if the subscriber accessed the service from his home country or was roaming. As another example, one can also correlate the radio access technology indicator to provide innovative billing solutions to the customers. Say free Wi-Fi service from midnight to dawn. Let's now take a look at what happens as you step into VoLTE and mobility comes into play. Well, one important thing to note is that it's your same IMS engine that is already chugging along well. It's essentially the same core that will be used for voice over LTE. So operators can follow the path whereby they first deploy Wi-Fi calling, build their services on IMS core. They can really experiment and innovate and build their services, and then extend their radio coverage and introduce voice over LTE. The elegance of the architecture is that you are already pretty much soft launching your voice over LTE from a core perspective by deploying Wi-Fi calling. Alternatively, operators can launch voice over LTE and use Wi-Fi calling to complement coverage during the initial RAN rollout phase. Each strategy is different and has its own set of merits, but the IMS core is centerpiece across both technologies. The EPDG introduces mobility support between Wi-Fi calling and VoLTE. Irrespective of which direction you go, hand in or hand out, the IP address is preserved at the P gateway, which acts like your anchor point. Services as complex as we have described have typically taken months and even years to deploy. Is that a hindrance to the decision to deploy the service in the first place? Well, it pretty much was up and until now. And what changes the equation today? The answer is virtualization. All of our solution components can be virtualized in an NFV-compliant, hardware-agnostic fashion and deployed on cloud-based infrastructures. All our products are based on the common virtualized M1 software platform designed for reliability and scale. In a Wi-Fi calling context, the end-to-end solution can be offered in a unique industry-leading offering that we call virtualized Wi-Fi calling in a box. This really allows operators to start with a lower footprint and grow as you need. Virtualization is a means to fundamentally change the cost equation of how next-generation networks will be built and managed, accelerating significantly the time to market. What does this mean to you as an operator? Well, you can get your service up and running in a couple of weeks. Finally, I'd like to share a few Wi-Fi calling deployment examples. Mavenir is privileged to be associated with the first Wi-Fi calling deployment with T-Mobile. And that really gave us insights into solving real-world problems well ahead of time. The service as we see today is really cool and appealing to the end users. Well, it was a fascinating journey to reach to this point. Initially, it was about replacing UMA, a technology that didn't really take off given the limited handset support and associated device royalty fees, making mass adoption an expensive proposition. So they decided to shift track and adopt IMS. Now, having gone to IMS, they were able to leverage the benefits of a widely available technology and an open ecosystem. What that allowed them to do was press the pedal on innovation. So very quickly, they shifted from solving a problem to creating value purely via service innovation. They will continue to innovate in incremental steps, launching new services like RCS along the way. Our solution consisted of a full-fledged end-to-end converged IMS core for VoLTE and voice-over Wi-Fi with full service parity. Johan touched upon this earlier. The Uncarrier 7.0 campaign centered around next-generation Wi-Fi calling, HD voice, Apple device support, and seamless mobility was a true game changer in the industry. The commercial launch was in Europe with a Tier 1 operator. They too are solving a problem. What's different? In this case, they are doing it for their 3G subscribers. To improve indoor coverage, they direct their subscribers to download a Wi-Fi calling app. It's an easy and intuitive app which integrates with the existing address book, also displaying call log information. In addition to an IMS solution, we provide the downloadable Wi-Fi calling client. Behind the scenes is our client provisioning server, which makes sure that the clients are installed and activated in a transparent manner for the user. It all works seamlessly, and this is a critical success criteria from a service lifecycle perspective. By following this approach, this operator was able to leverage their investment in 4G to address their 3G subscriber base. How clever is that? The proof in the pudding was really a longer average call duration on Wi-Fi coupled with increased Net Promoter Scores. Now I would like to summarize some of our lessons learned from our deployment experiences. Service parity and transparency is key, as we saw in the use cases discussed. A service that is transparent to the user really becomes second nature, increasing the probability of success manyfold. A fully virtualized solution translates into faster time to market. This is the new paradigm of how networks will be built in the future. We've got the service up and running in a matter of weeks, not months. The next generation Wi-Fi calling adds the need for a proven, flexible, and scalable 3GPP AAA function such as the Aptilo SMP. Wi-Fi calling can really be the tip of the iceberg as operators are transforming their networks to all IP. As they continue expanding their robust service suite, adding new services like video calling, rich communication services, and WebRTC. Really an opportunity to leapfrog with service innovation. And lastly, we've seen that the evolution to voice over LTE is quite natural. With this, I would like to thank you all on behalf of Mavenir Systems and Aptilo for having taken the time to tune in to this webinar. We sincerely hope you found it informative.